number 6 begins with the definition of letting f be a function defined by f of x is 1 minus 2 sine of x, where x is less than or equal to 0, and e to the negative 4x for x is greater than 0. So, part A, show that f is continuous at x equals 0. To begin, we need to find basically that the function is continuous at f equals 0. And so we need to find where the left part of the graph and the right part of the graph come together. So we start off by showing that f of 0 as defined because x is equal to 0 at that part of the equation. 1 minus 2 sine of 0. And we know that sine of 0 is 0, so 1 minus 0 is 1. So we know that at that spot, at f equals x, or f of 0 is 1, right there. The next part would be to find the left hand of the graph. So we find the limit of f of 0, or f of x, as x goes to 0 from the negative side. And because x is less than 0 for this function, it would be 1 minus 2 sine of 0, and like we just did, that equals 1. So we know that the limit agrees on the left-hand side. For the right-hand side, the positive side, we use the limit of f of x as x approaches 0 from the positive side this time, and that is e to the negative 4 times x, and e to the 0 is 1. And of course, we know by the definition that because the limits agree and they meet at a certain spot and that point is defined, then we know that the f is continuous at x equals 0. So yes.
So for part B of number 6, the first part asks us for x not equal to 0, express f prime of x as a piecewise defined function. To do this, we need to take the derivative of both functions given in the piecewise. So f prime of x. We need to take the derivative of 1 minus 2 sine x, which comes out to negative 2 cosine x for x less than 0. Now, for the second part of the function, the derivative of e to the negative 4x is negative 4 e to the negative 4x for x greater than 0. Now, Peter will finish the rest of the problem.
Alright. For the second half of it, we need to find the value of x for which f prime of x equals negative 3. Alright. So we need to set each individual one equal to negative 3. For the first part, we have negative 2 cosine x equal to negative 3. To simplify this, divide each side by negative 2. Cosine x equals 3 halves.
Not right now, Miss Losey.
Jeff Carter, Trevor
We know that this
Oleszczuk,
can't happen.
Randy
We can't have an
Spalding,
x,
Peyton Gill,
cosine x
Frank
equal to 3
Stengel
halves.
to the main
So let's
office.
try the other half.
They probably didn't
Jake
hear you.
Easy, Keegan McGarriger,
Say it over.
Connor Cannon,
Just
Jeff
say it over,
Carter,
you're fine.
Trevor
Or wait
Oleszczuk,
till she's done.
Randy Spalding, Peyton Gill, Frank Stengel to the main office.
Where's that coming from?
Alright. So for this part, we added equal to negative 3, divided each side by negative 2, and we realized that cosine x can equal 3 halves. So let's try the other side. Negative 4 e to the negative 4x equals negative 3. Simplify, divide each side by negative 4. And to get x out of the top of the e, take the ln of both sides. Then the ln of e we know equals 1. So all we have to do is divide this side by negative 4 and that side by negative 4. And we have x equal to negative 1/4 ln
Problem C says find the average value of f of x on negative 1 to 1. So what we have to use is the average value theorem for integrals, which states that 1 over b minus a, the integral from a to b is the average value. So now what we're going to have to do is plug the numbers in and plug what we have in. So what we use is 1 over 1 minus negative 1, the integral from negative 1 to 1 of f of x dx. Now the problem we have here is that it's a piecewise function. So what we're going to have to do is we're going to have to add from negative 1 to 0, which is 1 minus 2 sine of x, and then from 0 to 1 we're going to have to use the function e to the negative 4x. So right here we have 1 half the integral from negative 1 to 1, and now from negative 1 to 0 we have the integral of 1 minus 2 sine x. Now we add on the other integral from 0 to 1 of e to the negative 4x. And now differentiate these, and we get 1 half negative 1 to 1 of x to the negative 2 cos x plus, this is from negative 1 to 0, and this is from 0 to 1 of 1/4 e to the negative 4x. Except that is negative. So this changes to a negative. Now all we have to do is plug in chunk to find the integral, and that is where PJ comes in. Sorry, I didn't leave you any room.
Well, you made one mistake.
Oh, did I?
This should be x plus
Oh.
2 cosine x. Realize you
Disappointing.
got it right. So yeah, now we have to substitute into the integral to solve. So bring the one. Hang on, I'm gonna erase your work, Mark.
Disappointing, PJ. Just get it right though.
So we bring the 1/2 out, and we're substituting in. So we get 0 plus 2 minus negative 1 plus 2 cosine of negative 1 minus 1 over 4, this is the chain rule, e to the negative 4x minus 1/4. And all of that is equal to 1/2 times the quantity 3/4 minus 2 cosine of negative 1
PJ, you're in the way.
minus 1/4 e to the negative 4th.
PJ, I'm gonna have to step in there and correct you. This is actually a 13, but good try.
Oh, well, little algebra mistake.
Wait, PJ, can you tell us what color that marker is?
Couldn't tell ya.
If you can't tell the color of the marker, how can you do calculus?
Well, it doesn't have a word on it, and that's generally how I identify colors. But I'm gonna go ahead and say it's orange.
It's red.